Hi, my name is Treu, and in this talk I will present you our paper Fashion-Guided Adversarial Attack on Person Instance Segmentation. I did this research in collaboration with Engi Ale, Huyen Gwen, Junichi Yamagishi, and Isao Ishizen. In the recent years, the numbers of images shared on social media have grown exponentially, combined with the learning capacity of deep neural techniques, and we get privacy concern, because it became possible to train illegal recognition system on social platforms. To prevent such things to happen, we need a solution to make photos unusable to those systems. We can emphasize that these solutions will be robust against classic transformation encountered on social media, such as JPEG compression, color filtering, rotation. Also, the proposed solutions need to preserve the overall picture's naturalness. Adversarial example is an elegant solution to this problem. It has been studied for a few years now, and we can divide it into groups. The first one focuses on digital level and attack primarily classification networks. The classic method, which is use the gradients, can craft adversarial example with ease. However, it is not robust against transformation. The second one occurs in the physical world, targeting object detection. By essence, real-world crafted attacks need robustness against all types of variation, but they usually miss the point of naturalness. One last thing, to the best of our knowledge, there is no previous work on attacking instance segmentation on digital levels. So we designed an adversarial example against person segmentation with the idea to explore the trade-off between naturalness and robustness. We take advantages of the texture transfer losses to infuse adversarial perturbation, blend with fashion style. By only focusing on closing region, we reduce the overall impact of our method. We also take the robust training of real-world adversarial attack and adapt it to our own needs. The framework we propose only attack closing region by first identifying such region with segmentation deep neural net. Then it automatically chooses from a fashion image corpus the one that minimizes the distances in the feature spaces. These fashion images is used in the texture transfer loss to hide the adversarial noises that is produced with the targeted person segmentation network loss. Note that in this work we only target YOLAC because it works in real time and at great performances. There is also a combination of two losses to reduce the noise and make the attack even more natural, namely the multi-scale structure similarity and the total variation. Lastly, we use the expectation over transformation to ensure the robustness of our method. In order to test this framework, we use the MS-COCO dataset with at least one person in the images, then manually remove images with no closing region. We end up with 1000 images. We take the average precision of YOLAC as the measure of robustness and the structure similarity index measure for naturalness. As you can see on the left graph, our proposed method not only managed to stay adversarial whatever the compression factors, but also maintaining a high structure similarity. You can also see here our method compared to the other, with associated adding perturbation. In this last part, we will discuss the effect of the adversarial training in the robustness. As we pointed out earlier, we use the expectation over transformation framework as the robust training, which consists of minimizing the loss over multiple transformation. As transformation, we use perspective shift, blur, color variation, noises, and JPEG compression. You can see the result on compression in the upper graph, and classic image manipulation uses as defenses in the lower table. The impact of this particular robust training is huge. It helps to reduce the sensibility against classic transformation usually seen on social media. Thank you for your attention.